Hello Silver Pascal coders. This video follows on from the previous video where one of the comments was talking about a feature which is perhaps the least controversial in the world of Pascal, and that is a writable const. It is so perfectly named that it will take me 10 minutes to explain to you how it came about, or why it exists, then why you should forget about it straight away or pretend it doesn't exist. So we're going to unravel this historical mistake and understand why this contradiction exists, and it may be key to also writing clean code. So let's dive in, shall we? So we've got a little program here. Nothing magical, in terms of what it will do, just calculate the radius of a circle. And here we have a constant, and here we are also trying to assign a value to it. And if we try and build it, it says that it's looking for a variable identifier here. But if we just do something as simple as give it a type here, and well, this time it built perfectly fine. So what happened there? So in, let's say, normal or modern Pascal, if we define a constant, then it's going to be read-only, and that's what the word means. It will either we can't change it in code, and its value is known throughout the whole program, and it may just substitute the value in depending on what the compiler does, but the understanding or the impact of what's going to happen is understood. So if we do this and we were to take out that, again our program will build. This is good, but by assigning a type we can then also assign a new value to it. So back in the early 80s, and I've got a picture from one of the early magazines to show you how this came about. Also, it was from the Australian Delphi user group, but back in the 1980s, you wanted to have an array, say, or a record with a known initial value, but without having to write initialization code in an initialization section. Truly, this would be a mountain of effort for the developer. So Borland introduced the idea of a typed constant. So where you assign a type to the constant like this, and what it actually did was to have a global variable that would be, let's say, dressed up as a constant. So the compiler treated the declaration like a variable in the data segment, a area of memory that could be changed. It was mutable, but it was also initialized for you, and it was a feature, let's say, that was built on convenience. Now, for also people who would have, say, a C background, then this would also have the appearance of a C static variable. For instance, if you were to wrap up that writable constant in a function having an initial value, then each time the function, or each time that the variable would be accessed, or if it were changed, the changed value would be then used. So what we would have here, well, what I might do now is to see if we can bring up this image here to show you what we're talking about. So just bear with me for one moment. So in this image here, you can also see a function here called getCount, which will increment the value of the counter and then returns the new value. Up here also you can see there is a captions and data records, which have also been assigned some values and are also constants. And what it says then in here is that we are referring to a typed constant, and so here are the examples. A pre-initialized non-simple type. A side effect was that the storage is allocated by the compiler to hold these strings. Additionally, this storage is global as opposed to local, which means it is allocated as the program starts and exists through the lifetime of the program. This last time would be irrelevant were it not for the key point that type constants are not by default constant. Instead, Borland made them writable and then act like initialized variables. Normal variables defined in the var section can only be initialized if they are non-local, meaning defined outside any subroutine. This is because the compiler only supports initializing global data, which it does by storing initialized data values in the exe itself. So initialized variables are pre-initialized in the executable, not by any code that executes. The fact that this typed constant can be defined as either local to a subroutine or globally therefore needs to be examined carefully, since a compiler does not support initializing items by auto-generated code. It follows that type constants are initialized in the same way as global variables by data being stored in the executable. Type constants are initialized at program startup and at no other time. So even if type constants are defined to have local accessibility, it has global storage and is initialized to startup, the implication is that any change made to a type constant in any subroutine will be persistent the next time that the subroutine is invoked. The type constant will still have the changed value, so they are equivalent of static variables in C. So again, if we look at the example in number 5 listing, the counter starts at 0, will go to 1, called again the counter goes to 2, called again the count goes to 3, and those values are being passed around. Obviously this also can cause a problem if your code is multi-threaded, so, and you've got calling that function from multiple threads, what value is it getting? So, that can cause a problem. However, Delphi 1 users took offense at the possibility of something being called a type, being a constant being called modified. So Delphi 2 introduced a compiler switch to fix the loophole, so that you can toggle the switch on the compiler page of the project options dialog to deny programmers the ability to write to typed constants. This switch corresponds to the $J or $writeable const in compiler directives. J plus or writeable const on permits type constants to be modified. This is the default for backward compatibility with Delphi 1 and earlier compilers, despite what Delphi 2 helps claims. $J minus or writeable const off makes typed constants truly constant. So here, this was from, let me see if we can find out where it was from, the Delphi magazine. In that there is pretty much the history of how it came about. So Pascal handbook now, if we can bring up that screen, then we can set, oddly enough, object Pascal does allow you to change the value of a typed constant at runtime as if it were a variable, but only if you enable the $J compiler directives or use the corresponding assignable type constants compilable option. This optional behavior is included for backwards compatibility of code which was written with an older compiler. This is clearly not a suggested coding style, and I've covered it in this note almost as a historical anecdote about such programming techniques. So it was introduced as a convenience way back when. What that convenience was or why it was introduced, we can only assume, but now it is just part of the history or perhaps folklore of Pascal, and perhaps one that is better not used. So we'll go back to our code now. So what can we learn from that little article from the Delphi magazine? Well, first of all, that the storage was allocated in the data segment. It existed for the lifetime of the program. Yes, it does have an initial value. So it's guaranteed to have that initial value when the program starts, but it can also be written to at any time. So when you're using a compiler switch, and remember that Free Pascal will use similar or the same directives as Delphi in this instance, so that J plus or the writeable const on is a backwards compatibility lifeline. It allows old or non-standard code to compile and maintains a tradition of the unchanging of something which is actually mutable. Why is it not recommended? Well, or why would we avoid it today? if you are using constants as we see them, as they valued, which won't change ever, and you don't allow your program to use writable consts, then if you are using them, then your code will fail automatically. Secondly, in the context of what a const is today, it breaks that fundamental promise of the const keyword. Developer who maintains your code will assume that the value is fixed and can lead to bugs when they realize that it can be changed unexpectedly. And perhaps the more modern way would be to just declare a global variable with using the var keyword, and then assigning values to it that way. So if you do intend for a variable to have a value that can change, the better way to do it then would be to declare it as a variable with a var in front of it. Don't make your compiler lie for you. So in summary, a const, or treat your const as read-only. Recognize that a writable const is a relic of a time. So hopefully that's about the end of this particular video. It's a piece of Pascal history that hopefully you will have gotten something from. And maybe now if you've got the urge, you might want to go up and clean up some of your code where you might be doing something like this and using a writable const. Now, are there other Pascal oddities that make you wince that you would not want to look at again? If so, let me know in the comments below and we could discuss them perhaps. But until next time, happy coding, and I'll see you on the other side, and peace out. Bye.